my name's Rowan Church. I'm a resident who works in northwest Tasmania, and I'm the Tasmanian representative on the DEA Management Committee. I just wanted to say how amazing this gathering is. I was at that first iDEA conference. I think we actually called it a gathering then because it was a small room and a very small number of people. And that was the first time I got involved in DEA, and because I left that gathering with such a huge amount of passion and energy to act on this issue. And living in Tasmania is wonderful. Tasmania is a fantastic place. I'd love you to come and visit, but it can be a very depressing place at times. And so being able to come here and see a room full of enthusiastic people on this issue gives me a lot of energy to go back to Tasmania with. Now, one of the things I think DEA is really fantastic with as an organisation is getting on and doing things, and our next speaker is a great example of that. Forbes McGain is an intensivist and anaesthetist at the Western Health. You can read about his profile in the conference handbook, but Forbes has certainly got on with things in his own organisation and now in a research sense, and I think you should make him welcome.
We've got some prizes as well for students only. Only one each, one keep our cheats. We'll go with some fun questions. Two parts to this story. One is about gases, because I think the story isn't quite known. The science is known, but I didn't know all this science, and I think it's really fun. And I also wanted, and NOAA, not biblical, National Oceanic and Atmospheric Administration. They're a great website, and I've pulled a few slides from there. Measuring carbon dioxide. It's not. You'll recognise the monitor in the background. It's an anaesthetic monitor. And it took a Rhodes Scholar to say that. It's a mixed message, isn't it? It's actually wrong. It's wrong. It was said to a person, as we just heard, it was revealed in a radio comment. Because carbon dioxide is invisible to my eyes, but it's not invisible to my machine. I measure it every second. And it is not weightless, but you can't smell it. So, first question, who knows why carbon dioxide, students only? I've given the answer perhaps down the bottom there. Oxygen and nitrogen don't absorb infrared energy, but carbon dioxide does. Why is that? Anyone? Any of the students? Why? And I think that's instructive, that we don't know why, but it's really important. And it actually goes back to quantum physics. And I'm not a quantum physicist by any means. I've sat down and tried to understand the Schrödinger equation with some physicists here at Melbourne Uni and found it extraordinarily difficult and impossible. But the story behind it is actually rather simple in a way, that the carbon dioxide molecule is diatomic. You've got two greedy oxygen molecules, oxygen atoms, and a carbon in the middle, and the oxygen molecules want the infrared, and they want to basically stretch and move, and they re-radiate the infrared energy. And it's, of course, it's actually mainly coming off the Earth where we're talking about. They, of course, will re-radiate some that's coming from the sunlight in the form of infrared, but it's mainly the stuff that's coming off the Earth that's the issue, and that's re-radiating back to the Earth. We all know that if we didn't have carbon dioxide in the air, it'd be probably negative 14 degrees or thereabouts on Earth. It'd be rather cool. So carbon dioxide does that, and so does many other things. This is my analyzer once again, my anaesthetic machine, and you can see desflurane and sevoflurane and nitrous oxide. They're all absorb infrared because they're all diatomic or polyatomic. They're just molecules, atoms, working together and each having different amounts of greediness for electron activity. Just as a little aside, here's a Hummer. I thought I'd choose the Hummer because it's such a wonderful machine. And desflurane, one of the gases we can use in anaesthetics, has an enormous global warming potential. One of the areas that Eugenie Kayak and other anaesthetists and I are very keen on is reducing our use of this gas because there are other gases that could be used instead. And me using this gas at just 1 litre a minute for 1 hour is like letting rip with a Hummer at 200 kilometres an hour ad infinitum. And that's an example there of the different types of gases you could use and the effects that they have. So 1 hour of our desflurane on the left-hand column there is equivalent to using a similar gas, but much more of it, and it's equivalent to burning 30 litres of petrol for 1 hour. Here's our little story of carbon dioxide again with infrared, and you can actually predict from mathematics and quantum physics that the carbon dioxide tends to stretch and bend at different amounts. It's really quite extraordinary what is known. Where's this? Second question to student. I'll give hints as we go along. Where is this? Hawaii, yes. I hope you're a student. Next question then. Why? Student? Less atmosphere, but why? Yes, that's true, but why are these things here? That's right, less atmosphere. These are obviously astronomical telescopes. We're on Mauna Kea, the White Mountain, and in the background you see another mountain called Mauna Loa, the Long Mountain. What's on there? That's where, oh, sorry, that's the picture across. You can just see the white dots. They're the telescopes right on the top of Mauna Kea, looking back. I have to say I'm a nerd. You all probably know that already. Because Hawaii is normally known for surfing. That's where this picture comes from. You've all seen this before. You saw a wonderful story from Dave Griggs yesterday. That's the story of the Earth breathing. So you know the story of it breathing in and out. I mean, if it was a dead planet, you wouldn't have that swing. The swing is really the northern hemisphere plants breathing in and out. The swing down as they breathe in during summer and breathe out during winter. The rise being what we know as carbon dioxide, fossil fuels. But then I read you to Hans Suess. Probably don't sound it correctly. The story of carbon-14 and carbon-13, I think, is one that's begging to be told, and we don't know it. And I think we should all know it. It's not that hard, but it does involve a little bit of physics. So basically, carbon-14 disappears within 5,000, well, it's got a half-life of under 5,000 years, so it's all gone by 20,000 years. So anything that's burnt that's fossil fuel doesn't have any carbon-14 in it, of course. Carbon-13 is interesting as well. Carbon-13 is stable. It's about 1% of all the carbon that we have. Plants don't like carbon-13 as much because this wonderful enzyme called ribisco, ribulose biphosphate carboxylase oxygenase, it doesn't like the carbon-13 as much because it's a bit heavier. So it doesn't suck it in as much through its stomata. And so you can pick that something that was living, in other words, photosynthetic, will take in more carbon-12 than carbon-13. Its ratio will be different to non-living carbon. And this is an interesting little picture, once again from NOAA. And this is on the axis, x-axis is time. This is the y-axis is per mil. In other words, it's very fine data. It's small amounts of differences between carbon-13 and carbon-14 in this situation. What it's showing, and is a very clear area of Colorado, is the reduction of carbon-14 because we're burning more fossil fuels, so the CO2 that is coming up from the fossil fuels is causing a gradual reduction in the amount of carbon-14 in the CO2 overall. Remember, most of the CO2 hasn't come from fossil fuels, but that which is having a greater and greater effect. And so the amount of carbon-14 in our CO2 is falling. And it's really interesting, you can pick the differences too and where you are. The red dots here are East Asia, as you imagine, fairly polluted, lots of carbon dioxide being released, and that's less than the blue dots, which is Colorado, relatively clean air. So that it also picks, the story is really beautiful, it's really detailed. So the bottom line of this one is that there is less carbon-14 in fossil fuels, and there's less again, particularly if you're in an area where there's lots of fossil fuels being burnt, such as China. And this is one of the cruxes. It's a busy slide. You've already seen the pink part of it, which is the breathing in and out of the Earth, and it's the rise of the CO2. And the top one's really interesting as well. It's the blue line, which you may not have seen before. Once again, it shows the breathing of the Earth. And this is the ratio of carbon-13 to carbon-14, sorry, carbon-13 to carbon-12. So when the drop, you'll see that left-hand line there, you're seeing the drop, the nadir of the CO2 as the Earth breathes in the northern hemisphere and photosynthesis gets going. That is when there's the peak of the carbon-13 to carbon-12, because what's left over is the carbon-13 out there that the plants are not sucking in. So that swings up, the ratio, it's just a ratio, while the CO2 falls down. And then when it gets to the northern hemisphere winter, the amount of CO2 starts to rise, but the amount of carbon-13 ratio starts to fall because the plants aren't sucking so much in. And the story is really beautiful. I mean, here we are in Alaska, and you're seeing the swing is much greater in Alaska than Hawaii. So the swing is dropping 20 parts per million of CO2. And at the same time, and that's because, you know, they get the boreal forests and the great big forests of the northern hemisphere that are still there, And the carbon-13 to carbon-12 azimuth, the peak, corresponds beautifully with the drop in CO2 when the plants are busy breathing in. There's photosynthesis going on. So once again, that's the ratio of the amount of CO2 carbon-13 starts to rise up because the plants are bringing in all the carbon-12, and then it starts to fall back again because the plants are not photosynthesizing as much. It's a really detailed, exquisite story, and it just goes on and on. In the South Pole, you don't get the same swings, and the swings the other way around because you're in the Southern Hemisphere. So that before we saw those drops in CO2 in sort of September, October, but in the South Pole you see the drops, but they're not really that dramatic around our summertime in January, February. And also you do see the gradual drop of carbon-13 becomes more negative with time, but it's not swinging as much because you don't have as many trees. So it's diatomic. No one won the prize. There's no prizes won yet. It's got a fingerprint, just like all the other gases that I use. It re-emits energy, and it's just physics and chemistry, and you can't deny it. Year in, year out, everywhere, carbon dioxide rises. It's higher in the northern hemisphere than it is in the southern hemisphere because that's where most of the CO2 is coming from. It swings beautifully according to local plant activity. We've mentioned the sewers effect that the carbon-14 is falling due to fossil fuels, and furthermore that plants take in less carbon-13, so that the carbon-13-12 ratio is falling from all those old trees that died hundreds of millions of years ago that we're now burning. Part 2, the part you probably wanted to hear about. But I hope you enjoyed that. So you've seen this figure. Kate Charlesworth gave us a similar, more updated story, but the story is sort of basically the same. Here's our CO2 emissions from the United Kingdom National Health Service. The big takeaway, of course, is that procurement, the blue stuff that we take into the hospital, is more important from a footprint point of view than travel, me driving my Mercedes, no, I don't have one, or building energy use, so the direct heat and light that's being used by hospitals. So procurement's the big stuff. This study's never been done in Australia, and we wait. So I'll go through a few sort of little stories that I've been involved in. They're not necessarily the bigger picture, and I think there's lots of opportunity for other people to be involved in these things in other areas. I mentioned travel and energy already, just very quickly, because they're very tricky areas. You can see the vested interests, what we've heard a lot about today, that a hospital makes money out of people driving their cars and parking them and paying various companies to do so. So it's a very hard area to work in Australia. Energy and water is also quite tricky because water's damn cheap. And energy, although not being so cheap anymore, is still a small part of a budget for a hospital. There are real opportunities there, but they take a lot of time and effort, and they're big amounts of money that have to be spent in order to get things going. We're talking about life cycles briefly, recycling, reducing, and reusing. And I mentioned procurement because when I started this process about 6-7 years ago, actually in Alice Springs, it was around from the wrong way. Recycling first, and then we thought about, well, actually reducing and reusing is probably more important. The first thing we did is I took a photo when someone said there is no problem, and I said there is a problem because we've got 2 days of this, and that's beautiful polypropylene, which is oil. So that's our sterile wrap, you'll all probably recognise it, and they said, oh, there is a problem. So then we got together and we said, well, we better work out what this stuff is because most of it is actually not labelled, and so we got a little system going to work out. We basically contacted all the companies and we found out that this was all PVC. You recognise some of this stuff, and at the same time you got polypropylene and polyethylene. Not necessarily saying that you can actually recycle all these things, but we actually worked out what they are. We needed the baseline. And then we got together with a few companies in Melbourne, Red Group and SRM Recycling, Replas. For the oldies amongst us, the Vinyl Council doesn't have anything to do with records, but Baxter Australia, Intravenous Fluids, Sustainability Victoria, and we came up with our little PVC recycling, which to our knowledge, and the knowledge of Baxter, which is a multinational US company, had never been done before. And so it was really a lot of fun. And I know there are members of the committee and the group who've been involved with recycling out there. Will, go out the back, great to see you. Who've been involved in this sort of process. It's really good. It's lots of fun, and we're recycling now in the order of probably about 10 tonnes from Western Health per annum. So it's not large amounts, but it's starting, and it's probably something like 20 or 30 tonnes per annum from other places in Victoria. We've expanded to Tasmania, and Queensland's coming on board, South Australia, and hopefully New South Wales soon. And that's what it ends up as. So the intravenous fluid bags and masks and other things ended up as agricultural pipe in Dandenong, Australia, Melbourne. What happens with other plastics? It gets turned into places where I'd rather be, and bollards and other such things to walk upon. And we're getting quite a bit more of non-PVC plastics, which is really exciting. The good thing is also it's cost neutral to cost negative, because they come and pick it up for nothing. We've also had to be auditing things, and what the fun part of this is that before we started recycling, essentially we just had general waste and infectious waste, and what was interesting is seeing that yellow, that can't be right. You can't really have 50% of your waste as truly infectious, and infectious, why is it important? Because infectious costs 10 times as much as general, and so the separation wasn't going on very well. So we said, well, let's start with some recycling and have fun and re-audit things and spend weekends doing this. Yes, I remain married. So recycling is now about 22%. So this is quite exciting. I think it's quite exciting to get 22%, and that was without too much effort. And what worried me is I thought, oh my goodness, the yellow is now 33%. You saw it was almost 50. What's going on? Maybe we're contaminating. But in fact, it wasn't. It was just purely, what was really interesting is the dynamics of some of the nurses, and they were absolutely integral to this whole process. The nurses are the crux. Is that because they actually started to care about what they were recycling, they were able to recycle it rather than just chuck it away. They didn't care whether it went into general or infectious waste, and they started thinking, well, actually, I can move two schemes along and away from infectious waste, not general recycling. We can recycle it. It never had blood on it anyway. It was never infectious. So that was quite exciting. Although a third of hospital waste could be recycled in the operating room, it was quite simple to recycle about 20%. So we didn't get all the way by any means, but it was good. And the infectious contamination, although it's always possible, a human system, was no different. In fact, it was slightly less than before we started it. We mentioned, yes, segregating was good. Paper, I mentioned, is problematic, and we've got ways underway to try and change that, but paper's still a bit of an issue. At the end there, you saw increasing amounts of single-use items. It's a whole area that we don't really have time to touch on too much, but we can ask questions later on. And I mentioned that recycling is a pretty tough gig. You see that by the Dickensian-type industrial factories that are doing this. They're on a pretty tight margin. Single-use items, as I said, we unfortunately don't have time to talk about. It's a really big problem, and it's a very difficult one. It's a bit like travel and things like that. It's really hard to work on. So we have focused on things we're able to do things about. We talked about breathing circuits. This is a really minor topic. I mean, for most people here, who cares? But for me, it was actually a really important one because I think it was one that could be changed. And so we wanted to see whether or not there was some evidence, although it was really slim, how often you wash your anaesthetic breathing circuits. Every patient has a single-use filter that's chucked away after each patient, but that separates them from the machine. And the breathing circuits are sort of protected in a sense by that filter, and the next patient as well. So we wanted to see whether washing it at reduced frequency changed the micro. And so we jiggled these circuits around, we installed some sterile saline into them, and we looked at our bugs, as it were. We planted, we had fun at late hours, and did that. And what was really interesting after 15 months of pain and woe was that contamination rates were not worsened. They were essentially the same, and it related much more to the emptying of the circuit. So in other words, you had to make sure that the water was dumped at the end of every patient, because bugs aren't really interested in plastic. They're much more interested in water and people and things like that. So it wasn't really so much of an issue. And so that was quite exciting. Small funds, we're talking about $5,000 for Western Health you'd be saving in the washing and detergent and other things. We didn't even bother to include labour, but that's non-labour costs. And reasonable amounts of water and electricity. So that was quite exciting. It was good fun. I mentioned life cycle assessment because I think it's something that's coming our way. I think it's really important. It's basically the whole picture of how you work out what a life of something is, whether it's reusable or disposable. Generally, we don't know what's going on. This cartoon tries to show the sort of story, in other words, the whole story of something. There's a whole scientific method behind it, and it's been great fun working with people who are knowledgeable in this area. And there's a whole standard behind it, and Coca-Cola was actually one of the first companies to really get this going. They were comparing plastic to glass. And I just mentioned one of our little studies that we looked at with, you can see, reusable versus disposable trays. And you could use either one, and it really doesn't doesn't really matter which you use from a financial perspective, although it ended up being that the reusable was a little cheaper. And that from the CO2 perspective in good old brown coal Victoria, don't worry too much about the other parts of the slide. So I'm just going to, so the grey, which is a little bit hard to see, that's the reusable green one, and the yellow is the disposable one. There isn't that much difference between the actual amount of energy or CO2 that's being used, whether you wash it or just chuck it away with a disposable one. So that's quite interesting. Tasmania would be down here, but in other words, much better. But Victoria didn't really make that much of a difference. What tends to make a difference is this red, which is the cotton and paper, so the extras that are sort of being thrown in, which aren't always used anyway. 1 minute, even better. And I mentioned that it's not always the case, though. It's not always the case that it's going to be better to use reusables. And here's a classic example. So you saw those pictures of central venous catheter kits, insertion kits. You can see if you're on dirty Victorian brown coal, which is what I am at Western Health, it's rather different. If I was at the Royal Melbourne, I'd be on cogeneration gas, and the difference wouldn't be that much different. In other words, single use can be beneficial from a CO2 perspective. I mean, there's lots of other things you can look at, but purely from carbon point of view, if you're on brown coal, it makes it really hard. And why is that? Sterilisation. It takes 6 times as much energy to go from 99 degrees to 100 as it does to go from 1 to 99 degrees. In other words, that phase change of converting water to steam. Last question. We've still got 3. Who wins? Who's got the lowest footprint out of all of these places? Students, please. If you had a kilowatt hour of electricity, which would have the lowest CO2? Very good. Who said that? You get one. Okay. Yes. Tasmania is doing very well. South Australia's actually come down a bit from that with our wind at 25%. It used to be about the same as Queensland and New South Wales. I win. I'm in Victoria. I win by miles. And New Zealand wins, really. They're way down there. And so what that really sort of says is maybe they could help us, but more importantly, they should all be on reusable because it makes it much easier to be on reusable. Summarise, there's all these issues. There's a lot of lack of evidence in what I'm doing, but that's a very different story to Noah and the carbon dioxide story, which is grounded in quantum physics and the end of it all. So you can have this health minister's view of Victoria, of things, or you could be positive and you could work together and get on and try to improve the situation. I think it's an exciting time for GPs too. I think what we're really going to explore too is the photovoltaics on hospitals and things like that, because with the electricity prices rising, I think there's some real opportunities. And I mentioned, sorry, I have to quickly rush through that, I'm sorry. And I think that last quote is really important. And I'm sorry I've got the old iDEA logo, Eugenie. Nobody made a greater mistake than he who did nothing, because he'd only do a little. Thank you.
Thanks very much, Forbes. I think we've just got time for 1 or 2 quick questions. Don't have any by text at the moment, so we'll look to the audience if there's anyone.
Everyone was bored.
I've got a question in the middle there. And then one at the back.
Thank you so much for that. But what about from here? What is your plan from here?
So like, what's my plan from here?
Plan from here. So you've done all this research and you said there, like what you've seen, looks like you've made a bit of an impact at the Western, but what other steps from here are you going to be doing?
Yes. No, we could talk for a long time. So I agree that it takes, I think that word persistence comes out again, and planning. Having influence beyond Western Health is tricky because there's a lot of inertia. And it's also really interesting having discussions with people from the Department of Health about these issues. A very decentralised system in Victoria. I suspect it's the same in most other states. If it isn't, it will be soon. So that they're not really interested in affecting change broadly, but much more me marching around the various different health systems and different hospitals selling the message. It's hard. Even if you can save money, it's hard work, and I haven't made much progress yet, so I'll quite... The other problem is something called a part-time PhD, so that's mea culpa.
And I'll have the gentleman at the back for the last question, sorry.
Thank you. Why does New Zealand win in the energy stakes? Does it have anything to do with sheep?
No, geothermal, wind, hydro. They win. They've got the best mix.
Thanks.
Look, we'll have to move on from questions there. I'm sure Forbes will be very excited to take more questions and give away his keep cups at lunchtime, perhaps. Thanks very much, Forbes.
Thank you.